Today in this video I will explain one of the important topic in the structure of atom, that is the wave nature of a light and wave parameters. So once you can look at here, just it is the one of the wave. Here according to the theory of the energy transferred from one body to another body in the form of the wave. The energy is transferred from the one body to another body in the form of the wave. Those waves are travel in the space with the speed approximately 3 into 10 to the power of 8 meters per second. Whenever the light or the light like sources, they are traveling like a wave motion, and they have two types of the fields. One is the electrical field and the second one is the magnetic field, and here it is the wave direction. So all the electromagnetic radiations or the waves, they will travel even the vacuum. Why? Because due to presence of the electrical and the magnetic field. So with this wave, I am explaining some definitions like a wavelength and frequency and a wave number and velocity of light. You can watch complete video. Now, what is the wavelength? What is the wavelength? Once you can look at here, just it is the wave. Now the distance between the two waves, two height of the waves, that simply called it is the lambda. And here the height of the wave we are called it is the crest, and the depth of the wave we are called it is the trough. Now the distance between the two neighboring trough or the crest or the trough, we are simply called it is the wavelength. Once again I am repeating the definition. So wavelength. What is the wavelength? The distance between two neighboring trough or the crest in the wave known as the wavelength. And here the wavelength units, the length units are most probable cases we are using as the meters or the centimeters. But here the wave is the very nanoparticles or the microparticles. That's why we are using here angstroms, nanometers and micrometers. As you know that 1 angstrom is equal to 10 to the power of minus 8 centimeters, or 1 angstrom is equal to 10 to the power of minus 10 meters, and 1 nanometer is equal to 10 to the power of minus 9 meters, that equal to 10 to the power of minus 7 centimeters. 1 micrometer is equal to 10 angstrom, and 1 picometer equal to 10 to the power of minus 10 centimeters, that equal to 10 to the power of minus 12 meters. So wavelength is nothing but the distance between the two neighboring crest or the trough in the wave is called as the wavelength. This is the crest and the trough. The distance between the two neighboring crest or the trough in the wave is called as the wavelength. Next one is the frequency. So what is the frequency? The number of waves. The number of waves that pass through a given point at 1 second time is called as the frequency. The number of waves that pass through the given point at 1 unit or 1 second time is called as the frequency. So frequency simply we indicate with the u or the nu. The nu is nothing but distance traveled by the wave in 1 second divided by wavelength of a radiation. So nu is nothing but speed of a radiation or the wavelength, or c by lambda. Once again I am repeating. So what is the frequency? Just here the number of waves that pass through given point at given point. Just here I am taking it is the 1 unit point. At the given point, how many number of waves that will be traveled at 1 unit or 1 second time, it is the frequency. Now here the frequency, most probable cases we are using into the second inverse or the cycles per second or hertz, or 1 cycle per second is equal to 1 hertz, or cycle per second or the hertz. Okay students, once again I am repeating frequency. The number of waves that pass through a given point at 1 second time is called as the frequency. Next one is velocity of light. Velocity of light. The velocity of light just we are indicating to like a c. So what is the velocity of light? The distance traveled by one wave in 1 second is called as the velocity of light. The velocity of light is equal to the frequency into wavelength. The velocity of light is equal to the frequency into wavelength. The velocity of light or any electromagnetic wave depending upon the wavelength. So c is the velocity and the v is the frequency and lambda is the wavelength. So this is about the velocity of light. So what is the velocity of light? The velocity of light is equal to 3 into 10 to the power of 8 meters per second. This is the velocity of light. Once again I am repeating, the distance traveled by one wave in 1 second is called as the velocity of light. The velocity of light is equal to the frequency into wavelength. Velocity of light we are indicated by the c, that equal to v lambda, c equal to v lambda, that is the frequency into wavelength. Most probable cases, all electromagnetic waves that is travel into the same velocity, that is the 3 into 10 to the power of 8 meters per second. And next one is the wave number. Wave number simply we are indicated like a v bar. So wave number is nothing but the number of waves spread for centimeter or the reciprocal of the wavelength is called as the wave number. The number of waves spread for the centimeter or the reciprocal of the wavelength are known as the wave number. So wave number simply we are indicated by v bar. So that equal to 1 by wavelength, that is the lambda of a radiation. Now v bar is equal to 1 by lambda. V bar wavelength or wave number is inversely proportional to the 1 by lambda, or v bar equal to frequency by velocity of light. Once again I am repeating, wave number. The wave number we are indicated like a nu bar. The number of waves spread for centimeter or the reciprocal of the wavelength are known as the wave number. So wave number nu bar is equal to 1 by wavelength. So here v bar is equal to 1 by lambda, or v bar equal to frequency by velocity of light, v by c. So that is about the wave number. And next one is the time period. Time period we are indicated like a t, time taken by the wave of one complete cycle. So once you can look at here the time taken by the one wave by the complete of one cycle or vibrating is called as the time period. See, just the time period we are indicated by the letter is the t. T is inversely proportional to the wavelength, that equal to lambda by c. So once again I am repeating, the time taken by the one wave complete the one cycle, that is nothing but called as the time period. Next one, amplitude. So once you can look at, just here it is the wave. In the wave it is the height of the crust, and here it is the height of the crust, and here it is the depth of the trough. Now amplitude simply we are indicate like a. Amplitude simply we are indicate like a. So the amplitude is nothing but the amplitude of a wave is the defined as the height of the crust. How much height of the crust or the depth of the trough, that simply we are indicate like a amplitude. Okay students, if you like my video, give me the like and don't forget to subscribe my channel. Thank you.